everybody, Jason here from AV Pro Edge, and I am very happy about today's webinar. We have a very special guest, Danny from HDBaseT. Danny, how you doing?
Good morning, Jason. I'm perfect, thanks. I'm doing great. How are you doing?
I'm good, man. Thanks for asking. Nice to see you. Nice to hear your voice. I haven't had a chance to see you in quite a while, so this is cool. I'm glad you're doing well.
I'm great. I'm honored to be here. It's a real honor to be a guest on your webinar. I know you've been very busy, and
Yes.
to be part of this is a pleasure and a joy.
Cool. Well, thank you so much. I really, as we're doing these educational webinars, you guys, our partnership has been so strong since I've worked for AV Pro. I've attended some of your trainings and was just totally blown away. And I was like, let me get Danny on here, and we'll get a little into the technicals of HDBaseT, because I know a lot of integrators out there. To them, HDBaseT is just plug and play, and it works like magic. So I wanted to talk a little bit with you about what makes that magic happen, and what do installers do when they do run into problems that might be HDBaseT related in the field. And then we'll kind of spend some time at the end to talk about some really cool stuff, and that's the HDBaseT 3.0 and the new Valens chip. So I am very excited to talk to you today.
Yeah, I'm very excited to share that with you and all of the guys listening in. As you say, it's you are one of our authorized trainers. I see you're wearing your T-shirt.
I got my shirt. Yep.
There you go. So you maybe more than anybody appreciate what goes into HDBaseT and into the technology. And as you say, plug and play is what it is. It's what it was designed to be. And there's a lot of technology behind that in order to make that happen.
Right.
Now, of course, we have about an hour or so available to us today, and you will know that to earn that T-shirt that you are wearing, you had to sit through 2 days of me drooling on about the ins and outs of our technology. So so we can't obviously cover everything, but we'll dive a little deep into what we're doing and how we do it. In particular, how do we get so much bandwidth out of what is a fairly simple cable, enabling us to work uncompressed and all this kind of stuff. So we'll be focusing on some of those details.
Excellent.
And yeah, of course, we can open this up to questions. And if we don't have time to answer all of them, then I invite everybody to either reach out directly to you. They can send their questions,
sure.
Either through the GoToWebinar app or directly to you, and forward them to me, and we'll get answers to every question. We don't want anybody to go away from here feeling they didn't have an answer.
So, guys, I will be watching the question box here live as we talk with Danny. So if you have any questions that come up, feel free to chime in and don't be shy. And then we'll leave a little bit of time at the end in case there were some questions we couldn't get to. And then, of course, you guys will have my email address and everything, jason@avproglobal.com. If you have any questions we don't get to throughout the presentation, just shoot me a message there. We'll get those questions answered and make sure that you've got the information that you need. So excellent. So Danny, with that being said, I believe you have some things to show us, and you're going to share your screen.
I'm going to do share my screen, and let's see if we get this working correctly. Just 1 second.
Sure thing.
Are you seeing that?
Yep, I am. I'm seeing your presentation. It looks like I'm seeing the presenter mode. I can see your next slide. That's okay. This is where things get wonky. There you go. There's one. So guys, real quick, I just want to call out, there's a slider bar on your screen right now, and you'll be able to make Danny's slideshow a little bit bigger if you need to see it better. So grab that slider bar, slide it, make the size you want, whatever you're comfortable with. For those of you who are listening to the recording, the slider will not work. This is only for the people who are watching live, just FYI. And Danny, what you may do, I can see the GoToWebinar control panel. There's a little orange arrow at the very top that'll hide that for you. Boom, there you go. Okay, great. Right. So I see you, I see the screen. So yeah, let's get rolling.
Well, perfect. So once again, many thanks for inviting me on here. As you can see, Danny Shwartzberg, Daniel Shwartzberg, I've been called different things over the course of my life, some of which I unfortunately cannot repeat here. But for the purposes of this, I'm the Director of Customer Experience at the HDBaseT Alliance. What that means is that basically I'm responsible, if you like, for ecosystem education, ecosystem development, both in terms of our partners, in terms of installers, integrators, and so yeah, you find me at shows, you can find me online. I'm doing training courses and so on and so forth. That, in a nutshell, is what my responsibilities are at the Alliance. Now, for today, let's have a look at the talking points. That's there. Hello. Okay. You kind of, already tipped the crowd off, but this is what we're going to go through very quickly, a little bit more about the Alliance, of course. Then get more into our technology, what's the use case, why we need it, and as I've mentioned, we'll dig a little bit deeper into how it works. I've actually changed the order around a tiny bit. Let's plug from there straight into Spec 3.0 and the new Valens VS3000 Stello chipset. And we'll save the troubleshooting to the end simply because the troubleshooting is applicable to everything that I'll have been talking about.
Sure.
But as I've said, we can take this wherever anybody wants, where the questions go. Of course, Jason, if you have anything specific you would like to raise,
totally.
Let's go for it. All righty. So a little bit about who we are. Well, this is our mission statement, okay, and it's really very simple. The HDBaseT Alliance is all about standardizing and promoting a technology, the HDBaseT technology, as the global standard for distribution of uncompressed, and that is critical, uncompressed ultra high def multimedia content. Now, we began actually with a technology that was developed primarily for professional AV segments, but nonetheless the technology has evolved over the years and has emerged into different market segments. I can tell you we have an entire development which is for the automotive world. So in other words, for in-vehicle connectivity, and I can tell you, I mean, it's maybe less relevant today, but I can tell you that Daimler, Mercedes-Benz are rolling out vehicles with our technology in it.
Awesome.
But on the more traditional market, it's related more to AV. So yeah, of course, we're talking about Pro AV. We're talking about things like medical. We're talking about industrial applications, consumer. Those kind of market segments. We see ourselves emerging in more and more. It can be in transportation. Pretty much anywhere you need to get audio, video, and control over distance, that's where you will find us. And we obviously, there's a lot that goes into this. So I would say that the four key elements of what we do are shown in the bottom half of this slide. Of course, we are a standardization organization. So in other words, we write the specs in conjunction with members of the Alliance. So, for example, we have different working groups. We have an AV working group. We have a medical working group. We have an automotive working group. All of these people are developing the spec in the direction that they feel is most appropriate to their particular market segment, to their needs. So we have the standardization. We have, of course, specs. On the other side of the business, we need to make sure that HDBaseT products that hit the market are compliant and meet the requirements of the spec. So we have our own compliance testing specification. We have our own recognized testing facility where HDBaseT Alliance members who are selling products, they send their products to us, to our testing facility. We test them, and then we give them the stamp of approval. By doing that, we allow them to use the HDBaseT logo. It also means that their products will appear in our list of certified products. And again, I recommend to everybody who's selecting HDBaseT products, only go to the list of certified products, which appears on the HDBaseT Alliance website. Of course, we have a lot of marketing activities. That can be trade shows, InfoComm, ISE are the big ones. Of course, in today's environment, we're not quite too sure when we're going to get back to the trade shows, but nonetheless, that's where we focus a lot of our energies, and of course, digital marketing. And then we have the market education that I touched upon earlier. So we have training courses for installers. We have training courses where we create new authorized trainers. And Jason, you, of course, wearing the T-shirt are one of those authorized trainers. You went through that 2-day course. We have webinars, white papers, you name it. So we're all about promoting standard, developing the standard for the betterment of the industry. We did start actually in 2010. That was when the Alliance was established. It's grown very quickly to more than 200 members. I think we've got somewhere like 210. It literally changes on a week-by-week basis. Sure. There's not going to be any quizzes on this. I'm not going to ask people to remember all of these. But of course, you appear there. We have the 4 founders. LG, Samsung, Sony Pictures, and Valens, who are the semiconductor vendor, the chip vendor, and the inventors of the technology. We have the contributor members, including AV Pro Edge, who actually can sit on those working groups who can help to write the spec. And then we have, an awful lot more adopters, and these are many of the companies that are actually making the products themselves and selling the products. So that's in a nutshell what the Alliance is. Like I've said, very, very busy, lots and lots of members, a lot happening with this technology in the market, in the industry. So why then? Why do we need HDBaseT? And I am assuming that most people know this, but nonetheless, should somebody have, I don't know, aliens have landed in the last 24 hours and not heard about HDBaseT, let's go for them. You go back a few years, I mean, this was the sort of problem that an installer and integrator was facing. Okay, many different cable types. I
remember these days.
You remember those days? And
oh yeah,
I remember them too. I used to have more hair before I knew about this problem. And these are the sort of things that have people losing sleep and pulling their hair out if you're an installer, if you're an integrator. A bunch of cables. And not only are there a lot of them, most of them are with molded connectors, so you have difficulty feeding them. And the guys who invented HDBaseT technology said, okay, there needs to be a better way.
Yeah.
And what they were proposing was basically to replace all of those cables with a single cable, okay, to create literally the ultimate standard for digital connectivity. And you might think, okay, great concept, that's got to be a super complicated, probably really expensive cable. But that could not be further from the truth. We are talking, of course, about standard network cables, so category cable, which can go very, very long. We'll talk about the distance in a few moments. It can, of course, be field terminated as well, so you can cut it to the distance you want. You can feed it through the conduits without a connector on it, and then you just crimp it off once everything's in place. So a very, very unique value proposition and a unique offering. And I can tell you that before the guys at Valens had silicon to show to potential customers, they went around with some slides. And they went to some very respected names in this industry, and they said, this is what we're planning on doing. And it was a hard sell. They were pretty much laughed out of every conference room they found themselves in. They said, well, you cannot do what you're promising to do on a cable like this, LAN cable, very, very noisy, very, very lossy cable, very, very simple cable. It was only when they went back with some working hardware that this thing really took off. So that's the concept. It's about getting all of these different signals onto a single cable. So we call that convergence. Of course, we are converging multiple different data types, different data protocols. And to add a little bit more flesh to that, what are we talking about? Now, this does depend a little bit upon which generation of HDBaseT spec we're talking about, which version of the spec, and therefore which generation of the Valens chipset. But right now, if we look at Spec 2.0, what are we doing? Well, first of all, we're talking about uncompressed video. When I say video, I'm talking about ultra high definition 4K video, all uncompressed, and audio that accompanies that. We are talking about Ethernet. A Spec 1.0 defines 100 meg. Spec 2 continues with that. Spec 3 is already gigabit Ethernet. So nice. We've got the convergence of the audio, video, the Ethernet. Spec 2 and now Spec 3 adds USB 2.0. Various control signals. It can be the consumer infrared. It can be UART, RS-232. Later versions of the spec added I2C control, and it can be the various control protocols that are actually nothing to do with us, in particular things like the HDMI CC or the DDC channel for the HDMI. So we tunnel those things through us. And the final element is power. Now, on this cable, we can actually drive, and again, this is a theoretical number, we can drive up to 100 watts of DC power. It's an extremely safe power delivery. It's kind of like PoE Plus, but it goes beyond that. It actually, as I say, can get you, on an ideal short cable, you'll get up to around about 95 watts of power. Nice. On a less ideal cable and like 100 meter or 328 foot cable, you normally have around about 72 watts of DC power available to you, and that's assuming a 48 volt supply level. So actually, with a single cable, you can power a display. Okay, and there are use cases. You know, I have to say, this is my dream, is to have in my bathroom a TV. Not a dream shared by my wife, I should mention, but nonetheless a dream that I have. And there are companies that make TVs, you know, displays for wet room environment, where the last thing you want is to have, you know, 110 or 220 volts of AC power in your bathroom going in the back of the TV. So literally, they have a single cable coming into the back of the display, and it is powering, you know, POH power of HDBaseT, as well as, you know, all of the other things that they need, the audio, video, the control, and everything else. So this is it. It's about convergence. It's about getting rid of the number of cables, and it is about going longer distances, because you know, some of those native interfaces, those native cables I showed you earlier, are very, very limited in distance, and that was another problem that the integrators and the installers were facing. Okay, my HDMI cable in practice probably, again, I'm talking about a passive cable, of course, probably can get up to 40, 50 feet, and I'm probably going to have to pay top dollar in order to get that.
Absolutely.
If I want to add to my installation now, you know, USB 2, that's limited by spec to about, you know, 15, 17 feet. And you can see some other things here. Of course, infrared, you need line of sight. So, you know, what happens when I want to have my Blu-ray player in the basement, and I'm now in my living room upstairs?
Right.
How do I control that with IR? So there's all of these issues. And of course, if we talk about the distance of the cable, we're actually limited by the shortest distance of any cable that I want to use. So even if a 50-foot HDMI cable would do me, you know, it's fine. The fact that I want to add now a USB cable, which is limited to 17 feet, means, okay, the end-to-end distance of my installation is now 17 foot, even if my HDMI can around 50. So again, it's convergence, and it's about distance. And like I mentioned earlier, look at these. I mean, HDMI, molded connector, USB, molded connector, RS-232, molded connector. You know, you want to start feeding that through conduit, it becomes a real pain.
Sure.
So I kind of put, if we wrap all of that, that is really the why. We needed distance, we needed less cables, but in order to do that, we had a number of challenges to overcome, and let's get into that now. So let's talk, you know, a little bit deeper. Let's scrape away, if you like, at the technology itself and dive in. HDBaseT follows the similar structure to the well-known OSI 7-layer model. I think everybody knows this, the SS7, you know, 7 layers, which basically describe all of the elements, if you like, define all of the elements that you need in order to establish a communications link. Okay, this is the same OS7 SS7 layer model that we know from the world of Ethernet, and that means we have, if you like, running from the top, we have application layer through presentation sessions, so on and so forth, into networking, and then at the very bottom you have the physical layer, which is really the interface, if you like, with the wire, with the physical medium. Now, what's unique about HDBaseT is that, yes, just like Ethernet, we have all of those 7 layers, but unlike Ethernet, we map everything out in hardware. So basically, this is a full stack technology with everything in hardware, from the physical layer up to the application layer. And you know, the physical layer, of course, that is you know, an interface with a piece of copper or maybe a fiber with Spec 2.0 of the HDBaseT version. At the application layer, that is actually mapped out in hardware. So the different silicon may support different interfaces. So for example, you may have a chip that doesn't support USB, and you may have a chip that does support USB, but that is all in hardware. Now, the benefit of this is that this means that the technology, it is super fast. Okay, what do I mean by super fast? I'm talking about a link latency, in other words, end-to-end across the 328-foot cable, a delay of less than 10 microseconds. Okay, this is super, this is near zero latency. People even tell me, now, why'd you call it near zero latency? This is basically zero latency. In particular, when you compare it to other types of technology, where the latency runs into tens, if not hundreds of milliseconds. So like I said, less than 10 microseconds. It's not purely a point-to-point technology. Many people think, okay, I can have a single transmitter, single receiver. You'll see here we do have an entire HDBaseT network layer. And that was actually implemented in silicon with the second generation of Valens chipsets based upon Spec 2.0. So we have the ability to create not only point-to-point links, but also a point-to-multipoint link. So, for example, you can consider a daisy chain, a point-to-multipoint, where I have a single source being replicated on multiple displays. We can also support multipoint to multipoint. So you can have, for example, several devices on the transmit side running to several devices on the receive side, all over a single cable. So it's very, very powerful. It's very, very scalable in terms of our implementation. We'll talk in a few moments about the different versions of the spec and the different bandwidths they support. But the underlying technology remains the same, irrespective of the bandwidth. So as I've said, full stack, all-in hardware, very, very fast. And that brings us back to what you said at the beginning. That means this is very much a plug-and-play technology. There's very little software development. A vendor like yourself needs to do very, very little software development at all. You can literally take the devices, plug in a cable between them, and it works. Yeah, you may want to implement some link monitoring software functions and stuff like that, but you need to do very, very little over and above that. So it's very, very easy to develop, and it's very, very easy to install. Okay, so I've been alluding to the fact that there are different versions of the spec. Let's take a look at what HDBaseT Spec 1.0 looks like. A few key points to mention here. First of all, of course, this is full duplex. What that means is that we are sending data simultaneously in both directions across the cable. And actually, we send data on all 4 pairs bidirectionally, full duplex. So in other words, it's not that we have 3 pairs going in one direction and 1 pair going in the other. No, we have all 4 pairs transmitting and receiving simultaneously in both directions, okay? It is asymmetric. What does that mean? It means that the downstream bandwidth is higher than the upstream bandwidth. So in other words, from my HDBaseT transmitter to my HDBaseT receiver, I have more bandwidth than in the return direction. And there's a very good reason for that, because my HDBaseT transmitter is my video transmission side. Okay, so I need a lot of bandwidth. If we're talking about uncompressed 4K, you can imagine the amount of bandwidth we need. The return channel is required for any data types that are not the video. So, for example, that can be the USB traffic or the Ethernet traffic or whatever. Of course, that USB and Ethernet traffic and the control traffic is bidirectional. So even in the main direction, we have some bandwidth reserved for those non-video formats. But nonetheless, the majority of the link bandwidth is dedicated on the transmit to receive side, is dedicated to the video. What we are running is up to 500 mega symbols, and I use the word specifically. A symbol is multiple bits of data being transmitted at any point in time in one go. And they are PAM16. We're going to talk a lot more about this in a few moments, okay? Just to say what that means is that with Spec 1.0, I have in my main channel, I have 8 gigabits per second of data. And in my return channel, which runs slower, I have 150 megabits per second, okay? 8 gig, 150 meg. Of that 8 gig, approximately 7.2 is dedicated to the video. The rest, there's a little bit of overhead, but most of the rest is for the auxiliary traffic, and the same, of course, for the return channel. So highly asymmetrical, running up to 328 feet. And I'm going to do this in old money. I'm sorry, I do it in meters because I can never do the conversion in my head. So we're talking about a 100-meter cable, which can comprise 3 sections, a 90-meter infrastructure section. So that's good infrastructure cable, 23, 24 gauge cable, and then 2 5-meter patches at either end. 90 plus 5 plus 5. That gives you your 100-meter, 328 feet. And we're talking about by spec minimum cable requirement of Cat5e unshielded twisted pair. Okay, so long cable, simple cable, carrying 8 gig per second, and 150 in the return channel. Okay. When we move to Spec 2.0, you will notice that the diagram kind of looks the same, but you have to dig a little deeper into the details. What you will see is that we still have up to 500 mega symbols of PAM16, so we still have 8 gigabits per second from transmit to receive. In the return direction, we've doubled up the speed, so we've now got 25 mega symbols. That means 300 megabits per second from the HDBaseT receiver back to the HDBaseT transmitter. That means we have more auxiliary channel bandwidth. Why? Because Spec 2.0, we added a bunch more native interfaces. So we added USB, we added I2C, we added sideband audio. So we needed more bandwidth for that, okay? But nonetheless, 8 gig main channel, 300 meg return channel. We also actually added the ability to retransmit packets. We'll talk about that in a moment. That's Spec 1 and Spec 2. We're going to leave Spec 3 for a few moments. So these are basically all HDBaseT products out there today are running either Spec 1 or Spec 2 products from Valens. So
Danny,
yes,
I'm sorry, I just have a question real quick. Right around what year, if you can remember, was the transition from 1.0 to 2.0? So like if an integrator out there right now might have an HDBaseT product, he doesn't necessarily know how old it is. Is there any way to tell?
Listen, the spec was released in 2013. The Valens chipsets kind of came onto the market late 2014, early 2015.
Yeah.
I would suggest the best thing to do is go to the list of authorized products on the HDBaseT Alliance website, hdbaset.org, and you can search for that product, and it will tell you what the class is, and the class basically tells you which version of the spec it is and what distance you can expect to achieve on Cat5e or Cat6a per video bandwidth, per video format.
Good, very good, thank you.
All right. So what's this PAM I'm talking about? Pulse amplitude modulation. We didn't invent it, but we are using it fairly uniquely. PAM is a signal modulation scheme, not surprisingly, where the information is actually encoded in the amplitude of the signal. So in other words, a different amplitude represents a different data. We can look at a couple of examples at the bottom of the screen. PAM2 is 2 level. That means I can either be a 0 and a 1, so each level encodes 1 bit of data. PAM4, I have 4 levels, and as you can see here, that means that each level actually encodes 2 bits of data. So the trick is that in order to send, for example, a PAM4 data symbol across the link, I set the signal level on the cable, and on the receive side, as long as I can identify that signal level, I can identify what the data it represents. HDBaseT uses PAM16, and this is what PAM16 looks like, okay? 16 discrete levels. And that means that we can actually encode on each symbol 4 bits of data. And that's how we can get a lot of bandwidth across the link without having to have an extremely high symbol rate. If the symbol rate's very, very high, the physical properties of the cable mean that we lose a lot of the signal power, a lot of signal strength, and it becomes impossible to work. So in other words, by slowing down the symbol rate, by having more bits per symbol, we can get a lot of bandwidth across. This is what the eye pattern looks like. This is at the transmit side, 16 very well-defined levels. The problem is when we run using, very cheap and nasty category cable, this is what that eye pattern looks like after the cable and the connectors. And you see that it's completely collapsed. Ouch, ouch is the word. And this is why people said you cannot do this, what you're trying to do on category cable. And the magic, if you like, the magic of HDBaseT and the magic that's inside the Valens chipsets is to take that compressed eye pattern and reopen it. Now, to get it looking something like it does on the transmit side, because only when I've done that can I possibly get the right sampling level of the signal, and when I get the right sampling level, then I can recover the data it contains, okay? Believe me, we have a lot of technology. There's advanced analog circuits in our chipsets. There are a very advanced DSP algorithms hardwired into the silicon to make this a possibility. Now, we actually play around with the PAM levels, though. PAM16 is the maximum, but we can change the encoding scheme, and here we can see here we can transmit at PAM16 or PAM8 or PAM4. And we change that for 2 reasons. One, we change it according to the bandwidth requirement. So obviously, video has a very high bandwidth requirement. We need to transmit at PAM16. We also give a quality of service to the data type. So in other words, when I transmit at PAM16, you will appreciate that because the signal to noise ratio is worse, that the PAM levels are closer to one another than PAM8 and PAM4, the levels, as you can see here, are much further apart. So when I'm transmitting PAM16, the chance of a data error is higher than when I'm transmitting PAM8, which is higher than when I'm transmitting PAM4. So let me tell you this, for video which requires high bandwidth, we need PAM16, certainly for 4K video. If I have an error in my recovered data, 1-bit error, which is like an error in one data packet of HDBaseT, which contains video information, that is part of an HDMI packet, which is part of an HDMI line, which is part of an HDMI frame, which is part of maybe 60 frames per second. That 1 bit of data will not be noticeable to the user. It has zero effect on the end user experience. On the other hand, the control packet, which is super important, If I have, I don't know, a 1-bit data error in a control packet, that could be the difference between on and off, or volume up or volume down, or whatever. So we play around with the PAM coding depending upon the data type and depending upon the bandwidth requirements. And if you look into the cable, you will see all the time. You will see you'll have a PAM 16, you'll have a PAM 8, you'll have a PAM 4. It's changing all the time, depending upon the data type, and that is all hard coded in the silicon. And what this means is that HDBaseT is an all-delivered technology. In other words, unlike Ethernet, we will accept a packet irrespective, simply because we have effectively given the quality of service through this subset modulation that you see on the slide. That said, Spec 2.0 did introduce retransmission, which is carried over onto Spec 3.0. And what that means is that should we receive an error packet, we can ask for it to be retransmitted. And we see that here. I send a PAM 16 packet from left to right. We identify through a CRC check that there's an error. We send a retransmission request back, and we send it as a PAM 4 message because it's a super important message. We want to make sure that the retransmission request gets back to the source, so we send it as PAM 4. And then the packet is retransmitted. You will notice what was PAM 16 is now PAM 8. That greatly increases the signal-to-noise ratio such that the likelihood of the packet, the retransmitted packet, coming across with an error basically falls to 0. I'm not even going to attempt to do the mathematics to prove that, but you can trust me. So in other words, we have this retransmission mechanism. It has 0 effect on the link latency. We actually can squeeze 3 of these retransmitted packets into the scheduling, into the flow of the data on the line without breaking the link latency. So all of this without affecting the 10 microsecond link latency. And what this effectively means is that at very high bandwidths, where we need more of those PAM 16 packets, this gives us more distance on the cable. So whereas, for example, with Spec 1.0 with Class A products, we could achieve 70 meters of 60, 70 meters of 4K video. When we introduce the retransmission with Spec 2.0, we can now do 100 meters of 4K. It gives additional 20, 30 meters. What's that? Additional 70, 80 feet of range, in particular at the higher end of the formats. Okay, so that's a very useful feature that was added in Spec 2. What can I do with all this bandwidth? Let's just basically focus on the video. Specs 1.0 and 2.0 support 8 gigabit per second, and as I said, that's around about 7.2 gig of video traffic in the main channel. That is the equivalent, actually, of 10.2 gigabits per second of HDMI traffic. So in other words, we can support everything that HDMI 1.4 threw at us. 4K 30 444, 4K 60 420, which is actually compatibility, backward compatibility that was introduced in Spec HDMI Spec 2.0. And we can do all of that uncompressed. This actually pixel clocks up to 340 megahertz. So if we think about 4K 30 444, that's actually 297 meg pixel clock. What happens though if we want to do HDMI 2.0 formats up to 594, you will appreciate that we cannot squeeze 18 gig of HDMI 2.0 into 8 gig of HDBaseT. We can squeeze 10.2 gig of HDMI simply because that includes a 25% overhead in HDMI, as you're well aware. The 25% factor. Plus, we can do some tricks. We don't do any compression. We don't lose any of the data. This is a bit exact data transfer across the link. No data is lost. There is no compression. But nonetheless, we can fit 10.2 gig of HDMI bandwidth into 8 gig of HDBaseT. If we want to go beyond that, with Spec 2.0, we said, okay, what we'll do is we will introduce a solution actually using a third-party chipset for visually lossless compression. This is actually display stream compression, DSC. It's a Visa specification, the video format guys. It's a very, very high quality compression system. It is visually lossless. It operates at a maximum of 3-to-1 compression ratio. If you think about something like JPEG 2000, that's a 20-to-1. If you think about H.264, 265, 100 and beyond compression ratio. This is 3-to-1, so very, very low compression ratio. It's also line-by-line compression, so it doesn't have to capture an entire frame and then compress it. So it's ultra low latency compression as well. It's a few microseconds, which is great because, as we've said earlier, the HDBaseT link itself is ultra low latency. So it doesn't really kill the overall link latency. And this was done actually with a chipset from Lattice, and you will see these products starting to emerge on the market to support 4K 6444 using this display stream compression. Okay, we've covered a lot of ground. I hope it's been clear. What we've been talking about so far has really been, Specs 1.0 and Specs 2.0. But as you've said, there's some goodies coming out, and that is basically all revolving around the Spec 3.0 from the HDBaseT Alliance, and of course the Valens Stello chipset, the VS3000. This is what Spec 2.0 looks like. We're talking about an 8 gig per second copper PHY. We're talking about 100 megs of Ethernet, and we have at the top here, you see those different native interfaces, the application layer of that 7-layer model. So we have our HDMI 1.4 support. We've got UART232 interface, infrared interface. Boy, that was harder than I thought.
See that 3 times fast, yeah.
Yeah. We've got some audio, we've got USB. Okay, so this is what Spec 0.0 looks like. If we roll back the clock to, wow, that seems like a long time ago. June
InfoComm last year. Yeah.
InfoComm last year. Wow, that was a long time ago.
It feels like it.
It does indeed, yeah, wow. Spec 3.0 was announced and officially released by the HDBaseT Alliance under the very, very impressive and intriguing banner of uncompressed 4K 6444. Okay, so a very, very big jump forward in terms of what is achievable with this spec. Okay, now if we dive down a little bit more into that statement, what do we see here? We see a 16 gig copper PHY. Okay, so in other words, specs 1.0 and 2.0 were 8 gig. We've doubled it up. We've gone to 16 gigabits per second, still over category cable. Okay, that's a heck of a lot of bandwidth, right?
Yeah, that's insane.
Yeah, that's insane. We have increased the Ethernet support from 100 meg to gigabit Ethernet. And we've added now a native interface to HDMI 2.0. Okay, so whereas before, of course, we were 1.4, now we've got 2.0. So if you think of all of the HDMI formats you can squeeze out of an HDMI 2.0 link, we can support those without the need for any compression. We've also, because we have also improved our return channel, we'll see that in the next slide, we've got more bandwidth there. So now we've got more bandwidth available to our USB as well. So I think the headline is that we've got a lot more bandwidth available to us with Spec 3.0. And what does the link look? Go ahead.
You didn't just add a little bit more, you doubled it.
We doubled it. Yeah. And, the same disbelievers who said it can't be done said it couldn't be done again.
Same thing, right?
And it's the proof of the pudding, as they say. And it's only once you actually bring to InfoComm already. At InfoComm, we had a demo of this up and running. The Valens guys got the silicon about 2 weeks before InfoComm. And it was working. It was working, straight out the gate. And we have a picture of it later. I'll show you that. So what is it? So in other words, we've increased the symbol rates. Okay, so we've increased the main channel. In other words, all of that video bandwidth comes from the fact we're now running at 1,000 mega symbols per second, gigasymbols per second, which are still PAM16, so still 4 bits per symbol. In the return channel, we've gone from 25 meg to 125 meg, and we've taken it from PAM8 symbols to PAM16 as well.
Oh, okay.
Crunch the numbers, 16 gig main link, 2 gig auxiliary return channel. Why do I need 2 gig auxiliary return channel? Because now I've got gigabit Ethernet. So in other words, 300 meg isn't enough for that. So I needed to have a lot more bandwidth. And like I've said, we've got more bandwidth now available for USB and for enhanced sideband audio channels, so on and so forth. We've added retransmission not only to the video link, so not only in the main link, but also in the return channel. And that gives us, ultra robust performance, even at long cable lengths. What we are recommending, this question always comes up, what we are recommending is using Cat6a UFTP. So in other words, foil on the twisted pair, unshielded nonetheless, if you want to maximize your performance. And I think that's a good message. And what I'm hearing is anyway, the HDBaseT spec was written to work on Cat5 UTP, unshielded twisted pair. Installers today, I'm hearing everyone is basically pulling 6.8. Okay, and you know, the better the cable, the more margin you have in the system, the more margin, the more robust, you get better signal to noise, the less likely you're going to have issues with the installation after you've left, and you know, and so on and so forth. So again, that's the cable of choice right now, but nonetheless, long distance, very, very high bandwidth. And of course, not surprisingly, Valens, the inventors of the technology and the semiconductor vendor, at the same time launched the new chipset. Like I said, it had arrived back from the fab, from manufacturing, literally 2 weeks earlier, and they got it up and running. And again, real revolution in what it's bringing to the market. Now, if we take a quick look at the evolution of the chipsets, so now as the first generation of chipset based on Spec 1.0, 8 gig, 150 meg, that's the link bandwidth, 100 megs of Ethernet, HDMI 1.4, some UART, and some IR. The T adapters, just to remind you, are the native interfaces, the native protocols that can be supported. Spec 2.0, the second generation of chipsets, 8 gig, 300 meg, addition of USB, addition of some sideband audio, still 100 meg Ethernet, and so on. Spec 3.0, again, huge increase in bandwidth at the link level, gigabit Ethernet. We've got some goodies in the chip that allows to do HDMI in and out at the same time, allows to play around with the HDCP, to terminate it, to add it, to convert, for example, you know, if you need to backstep from HDCP 2.2 or 2.3 down to 1.4, if it's allowed by the, you know, by the actual encoding on the disk or whatever content you're playing, we can do that. So we've got a lot more capabilities. What is super important to mention is that there is full interop. So in other words, I can take chipsets from any spec, and I can, you know, which are in different products from any version of the spec, any different chipset, and they will work. Of course, do not expect a 16 gig link to run at 16 gig when it's connected to a first generation chip running at 8 gig. Okay,
of course,
the higher level spec will always back itself off to work at the lower level spec. So in other words, if I connect a 16 gig VS3000 chip to a first generation a VS100 chip that runs at 8 gig, the link will come up, it will work perfectly, but it'll work at 8 gig. Similarly, do not expect a USB to work if one side of the link doesn't support USB, okay? But you will not get a blank screen, the link will come up, video will pass, okay? You'll get all of your, you know, you will not find yourselves running into interoperability issues. Some really neat things about this chip, the new VS3000 chip from Valens. We've already said 16 gigabit, that's 4K 6444 8-bit uncompressed. Of course, that means we can also run things like, because it's uncompressed, we can run HDR, we can 10-bit HDR, HDR 10 plus, we can run Dolby Vision because there's no compression being used. We have all of the tricks, as I mentioned, to do with HDCP. And actually, if you think already forward to HDMI 2.1, that's 48 gig per second. Well, I've got 16 gig available to me now with the same DSC that I talked about earlier. With a 3-to-1 compression, I can now support all of the video formats of HDMI 2.1 as well. Okay, so just with a simple DSC external compression, I've already got a migration path forward when HDMI 2.1 comes out. Okay, so a lot of bandwidth available to us. Super neat is that the same chip can operate either as a transmit device or receive device. We call this port duality.
Yeah.
And if you think about, until now, an equipment vendor like yourself would have to buy a transmit chip and you would have to buy a receive chip. And that meant that you would have receive products and you would have transmit products. Even if you're just making an extender pair, you would have one that would have to be a TX, you would have to have one that would have to be an RX. What I'm saying now is with this new chip, it's the same chip on both sides, which can be configured either by hardware, by software, or actually the system itself can realize, it can learn what's connected to it and automatically configure the video direction, you know, basically can automatically configure itself to be the transmit or receive side. That means that if you're making extender pairs or if you're installing extender pairs, you do no longer need to have a TX and an RX box. You can have exactly the same product. Okay, you buy 50 of them, and that's good for both sides of the link. Very, very useful. It also means if you're making a switch matrix, the port, the HDBaseT port on the back can sometimes be a transmit port, can sometimes be a receive port.
Right.
And again, extremely flexible. So my hardware basically becomes very, very flexible. It can be configured on the fly.
That, Danny, that was one of sorry, I was just going to say that when that debuted, that demo that you guys were showing, that was for me a, it's like, whoa, wait a second. Because as a manufacturer, and you just said this beautifully, but as a manufacturer now, that's half the amount of SKUs for all of our extender kits. So it's way easier.
Yeah, for you and your customers, the installers, the integrators, that's half the amount of SKUs they need. It's a huge advantage that it gives you.
And you don't have to worry about TX or RX. It's all the same.
You buy a box. You buy a box, it works. It doesn't matter which side of the link you put it. You buy the same box with the same end, and it works.
I love that.
And we have the ability to join these devices together. We call it DHDI. It's a chip-to-chip onboard chip-to-chip connection that allows us to create more complex topologies. So you can actually, and I have a little picture of this, like simple matrix switches suddenly become very, very easy to implement. Here's actually a kind of a high-level view of what the chip looks like. At the top, you can see all the interfaces. You can see we have HDMI in, we have HDMI out. So I don't need to have an HDMI splitter if I want to do local monitoring. I can have the same video in coming out locally on the same side. You can see the various other native interfaces, the Ethernet, the USB, audio, so on and so forth. You can see the green, which is basically the analog, the path to the analog front end to the cable. You can see on the left the DHDI, that's that chip-to-chip interface that allows me to join two of these things together. And at the heart of this chip is an entire HDBaseT packet switching core. And that means I can take any of these interfaces and basically feed them anywhere I want. So in other words, I can take the HDMI into the packet switching core. I can send it back to the HDMI output port. I can send it across the category cable link. I can send it over the DHDI interface to a partner chip that's sitting on the same board. So I can play around, I can move packets around throughout the system. This is not just what comes in goes out over the cable, or what comes in from the cable goes out over the native interface. I can create very, very complex pieces of equipment very, very simply. When I say complex, I mean in terms of the functionality that they can perform, that switching core enables us to do a heck of a lot, okay? And I'll show you an example of that in just a moment. Again, port duality, what does it mean? You can see here, simple extender pair, the same box on either side. Because the chip supports HDMI in and out, so my extender pair can support that as well, in and out for local monitoring. And it's either, I can just let software control it, or I can let the system itself decide which side did I plug the HDMI in. My HDMI source is plugged into the right-hand side, or in this case, into the left-hand side. The system automatically knows, okay, the video needs to go from left side to right side. Okay, it's simple as that. Here's the example I said of a blade, for example, for a matrix switcher. It can be input, it can be output. So no longer will I have a blade that's got 4 in or 4 out. I'll have a blade that's got 8 ports. I can configure that to be 4 in, 4 out, or 1 in and 8 out, or 8 in and 1 out, if anybody would want to do that. Very, very, very flexible. And there's the picture of the demo that you yourself said. You can see what you see on the wall under the displays are 2 evaluation kits from Valens. And each one had a source connected to it. And at the press of a button, we could change the direction. So in other words, we'd have video coming from left to right, and we'd have then at the press of a button, video coming from right to left. Should you misconfigure the system, if you try to send video in both directions, you will appreciate, that breaks the rules of the link, so it doesn't work. But nonetheless, the same chip in both sides, the same hardware in both sides, the video can be configurable from side to side, whichever side you want. And then this is what I was saying earlier. What DHDI allows us to do is to create, if you like, combinations. We can join our chipsets together. And here I have a simple matrix switcher with 3 HDMI in, 3 HDMI out, 3 HDBaseT ports. And all of that without the need to put expensive crossbars in, without the need to put expensive FPGAs in, with the ability to do HDMI termination, to generate HDCP termination, generation, conversion. We can do audio extraction and extract all in the same chip. My matrix switcher, this could be a perfect example if you think about a simple presentation switcher. Literally, you need three Valens VS3000 devices, and you're pretty much good to go. So again, a great deal of flexibility, cost savings in terms of the our customers, the Valens customers who are designing the boxes, and that hopefully feeds back into cost savings to the guys who are
totally.
Just a quick touch upon the video support. Yes, we've got the ability to support pixel clocks up to 594 megahertz. In other words, pretty much everything that HDMI 2.0 will throw at us without the need to do any compression whatsoever. That means uncompressed 4K 6444 with 8-bit color. There is no solution on the market that can do that uncompressed. You will hear other technologies claiming that they are doing, we don't compress it. I've been at a trade show, I've heard other technologies in front of an audience saying we do not compress. Sorry guys, the maths does not stack up. You cannot get 18 gigs of HDMI into something that's not 16 gigabits of HDBaseT without doing compression. I'm not going to name names. The compression may be small, it may be 1.5, it may be 2, but compression is required. We do it all uncompressed. And what that means is that we guarantee interoperability. So in other words, when you compress, you may run into problems. People do different compression schemes, okay? So by running uncompressed, suddenly you resolve the problem. It's HDMI 2.0 without any need to compress. We guarantee interoperability. And as I touched upon earlier, we can support the various different types of high dynamic range formats, HDR10, 10 plus, as well as Dolby Vision. Now, when you add compression, any HDR formats that actually the compression information, the HDR information is contained within the pixel data, is destroyed by the compression. Okay, so in other words, DSC and HDR10 works because the HDR information is not part of the video, so it doesn't get compressed. When you get to HDR10 and Dolby Vision, which employs metadata that is dynamic, that will be decompressed and destroyed if you use DSC. So basically, uncompressed means I support all of the different high dynamic range formats that are out there again.
That's great. That's really good to hear.
So listen, that's bringing you right up to date. That chipset is now, our customers are designing these things in. You guys can expect to see products with the Valens VS3000 Spec 3.0 products hitting the shelves probably immediately after the summer, I would expect it. Okay, I know there's a lot of work going on. This created a huge buzz at InfoComm last year, and an even huger buzz at ISE in Amsterdam. People want this solution. There are good compression schemes out there, don't get me wrong, but uncompressed, you can't beat it. You can't be uncompressed. So this is a game changer, and we're looking forward to these things hitting the shelves, and we got a feeling that you guys, I'm sure, are busy designing these things in as well.
Oh yeah.
These things are going to fly off the shelves as soon as they hit them.
You hit the nail on the head, Danny, when you said about InfoComm and ISE, these last two shows. Our main booth is typically just maybe coincidentally, luckily, but we're typically really close to you guys, right around the corner. Usually we'll have we'll have our own little small booth in your HDBaseT booth. And you're exactly right. I mean, everybody was just talking about the demo, and it was really cool because they had these LED lights going in one direction to the next. You push the button, and all of a sudden the LEDs, symbolizing the data transfer, started going the other way. And it's just one of those things for me where sometimes what I love about this industry so much, sometimes you'll see an idea, you'll see a product, and you'll go, man, I didn't even think of this. I didn't even think of even doing this, even making this possible. So the fact that you guys thought of it and engineered it, and that's really the mind-blowing part to me. And I appreciate you going through that. That's super, super cool information. And I know we've got a lot of plans, and having less SKUs and easier on the integrators. That's what this is all about. You guys are nailing it here. This is excellent stuff.
Glad to hear that. Yeah, I mean, again, it was important for me to share that. Even though there are products today you can buy, this is what's heading away. This is what's coming, and forewarned is forearmed. So people can already start to plan ahead and look forward to coming months when these things will be on the shelf.
Very good, very good.
Just very quickly, a few simple troubleshooting, tips and suggestions. And this may be, you guys out there, you probably know this better than I do, but nonetheless, sometimes a quick refresher. We've said it a few times in the course of the last 50 minutes. It is very much, our technology is very much plug and play, but there may be some problems that occur. Here's some tips for you, and it may not necessarily be related to the HDBaseT part of the link.
Yeah.
my first point to say to installers, always make sure that take HDBaseT out of link, make sure that the source and sync equipment are compatible. And by that I mean things like, not every display has all the features supported on all ports. For example, audio return channel may not be supported on all of them. New features like HDR may not also be supported, so don't expect HDR to work on a TV that doesn't support HDR. I mean that's obvious, but sometimes people make mistake. And try to take HDBaseT out of the system. So if you do see a problem with the link, try and replace the HDBaseT with a cable. With a regular HDMI cable, and you probably want to do this before you fitted it to the walls, because you're not going to be able to get a 328 feet HDMI cable. But nonetheless, try and take the HDBaseT out of the equation to make sure that source and sync equipment are working. Not all products support all the features that HDBaseT offer. That's great, because it means that manufacturers and therefore integrators and installers can choose the product that they need with the feature set they need at the price point they want. So in other words, there may be some interoperabilities, and you may have a product that supports USB on one side of the link and at the other doesn't. You need to be aware of this. We do have on hdbaseth.org the certified product lists. Go in there, make sure that the products you buy, first of all, are certified. That guarantees they're going to work according to the spec. Make sure that they support the features that you want. What about the cable? Of course, this category cable, the HDBaseT link, is super important. Make sure, installers, that you're correctly wiring and crimping that connector. We don't recommend untwisting more than about 1/2 inch. Make sure when you're routing the cables that you do so, with a view of what's happening around them. The last thing you want to do is finish the installation, everything's working great, and then when the customer in the evening switches on, the air conditioning unit, the link drops because you're close to the compressor. So, make sure that you're aware of what's going around and keep away from noisy sources. Maybe it's a performance issue. Maybe the cable is, you're operating at the hairy edge, if you like, of the cable. So try and maybe run with a shorter cable, see if that resolves it, maybe with a different video format. And of course, be aware that there are other cables in the system. Your HDMI cable, is that good? Maybe try replacing it. If you want to support, HDR, you need to have a premium, high-speed cable rather than the old one that you had in your case from 2 years or 3 years, 5 years ago. So make sure that all of the cables are good. We talk about shielding a lot when we do our training courses. Shielding is a good thing, but you need to know to use it wisely. So, you need to ground it at least one end. And that means everything in the system, the cable, the keystones, patch panels, patch cables, everything needs to be shielded if you want it to be continuous, if you want it to work. Pigtails are generally a bad thing. If you take a braided shield and you just roll it up into like a pigtail, those generate noise, so avoid doing that. And if you should have basically unshielding, like a break in the shield at any point, it may be your keystones, actually you can create antenna effects, and that's never good. That affects signal integrity. So be aware of what you're doing with the shields. Check the link performance. There are a bunch of testers out there today. I've shown a few examples here. These things, don't need to cost a lot of money. Some of them, as cheap as, a couple of $1,000. And they allow you really to probe what's happening on the link in terms of the performance parameters that are being pulled off of the Valens chipsets. And you can see on the tester how close you are to the margins, how close you are to hitting, problems in the future. It might not be today, but it may be, as I've said, if the fluorescent lights are switched on, or the air conditioning, or the roller blinds are put down, the electric blinds are put down. These things can help you identify potential issues that are around the corner by checking the cable and by checking, the configuration of the system as well, even.
So, Danny, we have, part of our troubleshooting tools that we have at AV Pro and Meridio are like these little, we call this the Fox and Hound kit. So I've got a generator, I've got an analyzer, I can test HDMI cables, I can test signal integrity, I can make sure my format's getting from one end to the other. So I know that I've seen in the past too, the company M Solutions. It sounds like they have something similar to this for the HDBaseT link. Can you touch on that a little bit?
Yeah, for sure. I mean, again, I'm not here to promote any products. You touched upon it. That's actually the test that you see at the bottom left of the image here. Yeah, that's a small handheld test. Like I say, it's honestly, it's not that expensive. I don't know numbers. You go to their website, they'll obviously be able to assist you. And what's cool about it is, as you can see, you can slot out. So you could, if you just want to test the cable, it's similar with the one in the middle here, which I think is from Teradyne. But you can actually just test the cable and make sure that the performance is good. But you can also connect this to to a real product, and you can check that everything's working there as well. So you can have your matrix switcher at one end, your tester at the other end. You can see how the link is performing. You can check configuration. You can do a lot of things with these. And like I've said, if you're installing a lot of HDBaseT products, and I'm sure you are, and I really hope you continue to do so for many years, this is a really wise investment. It doesn't need to break the bank by any means. Very, very useful pieces of equipment.
That's cool. I will say that troubleshooting with the right tools, I mean, that's everything, man. I mean, you go from just swapping things out randomly and just having a big headache and getting frustrated. It's so nice to just be able to plug in a device like that to test your HDMI, or a device like one of these to test your cat. I've heard other integrators in the past, they'll use like a very kind of basic, inexpensive, like a fluke meter or something to test the category cable. And I've seen an experience, and I was wondering if you had a little bit of a perspective on this. Why is it not a good idea to just use a basic like continuity tester for a network cable to do HDBaseT troubleshooting?
It's an excellent question. Let's think about it. A fluke, you're probably talking about a fluke which is running 10 gig Ethernet.
Right.
It'll give you some indication of if the cable, if you've forgotten to crimp one of the wires, or one of the wires is broken, you're obviously going to see a discontinuity. It's going to work. But HDBaseT is not a 10G Ethernet protocol, okay? So in other words, you are testing the cable using one protocol, which is called 10G Ethernet, for a use case that is something completely different, which is to send HDBaseT traffic across.
Right.
It gives you a basic indication, but if you really want to prove that your cable is working, that your installation is good for HDBaseT, you need to test using an HDBaseT tester. And people don't necessarily want to put their hands in their pocket and pull out a couple of grand every other week. But if you think about it, you buy a piece of equipment, as you said, Jason, the amount of time that this saves you, both when you're doing the install and in the fact that you don't have to come back the next day and the day after because you're just swapping things in and out because you haven't got good visibility into the system. I would say these things are going to probably pay themselves back within the first month or two, okay?
Time is money.
Time is money, and it's a cliche to say that, but things really can save you a bunch of time and a bunch of things.
I do want to point out to the listeners out there a very, very excellent resource on HDBaseT troubleshooting. I know you can find this on the HDBaseT website. I know you can find this on our website. They have a really handy guide called the HDBaseT 10 Commandments. And it's certain, there's 10 things on this list that it's like, always do this or always avoid this. One of the things that our tech support team runs into all the time are like the, the termination ends, the RJ45 easy ends. So getting away from things like that, using proper ends, and like I said, there's a list of 10 things that kind of help you with every HDBaseT installation. So I highly encourage you guys to go check out the HDBaseT 10 commandment list on our website or the HDBaseT website.
There you go. Yeah, available online and in 2 tablets of stone. But definitely one of the more popular and useful collaterals that we have to about it. Before we wrap, just very quickly, you talked about HDMI interface. If you can get yourselves a piece of HDMI test equipment, fantastic, like sync source, analyzer, generator equipment, perfect.
Right.
If not, there's some other stuff that you can try moving to a lower video bandwidth. That gives more margin in the system. That might point to a problem with some of the cabling. You may even be able to just, with simple breakout boxes, check the 5 volt, the HPD, hot plug detector, which are part of the HDMI interface. That can be tested quite simply. Make sure your EDID, if you've got manual EDID settings on the products, make sure you haven't set something to 4K 60 when the display only knows to handle 1080p or something like that.
Sure.
And pay attention to HDCP. That's always a bind of the Pro AV market. Pay attention to that as well.
Yeah, all great tips.
Very quickly, if you want to find more information, you can find us pretty much everywhere. We have our website, hdbaset.org. We've got blogs if you're into Twitter or Facebook or LinkedIn. If you just want to send us an email, installer@hdbaset.org. We are here to help. My role, as I've said, is to be a technology evangelist for this wonderful technology. So Daniel.s, no, sorry, Dan, what am I saying? It's getting way too late for me. Daniel S.
Too late, yeah.
Yeah. daniels@hdbaset.org. You are welcome to send me any questions you have. But Jason, if you want now to throw it open to the floor for anything that's unanswered, let's do it now.
Yeah, great. So guys, as I'm checking the chat box here and the question box, I actually didn't see any questions come in throughout the presentation. So Danny, I think you may have kind of had everybody in your lock there. Everybody was just locked onto you, and I don't think anybody had any real questions. But if anybody does, if you're maybe relaxing tonight and oh hey, I meant to ask him this, feel free guys, email Danny. You can also email me, jason@avproglobal.com. I'm happy to field those questions. So yeah, with that being said, Danny, thank you so much for your time. You're always such a wealth of knowledge and so fun to talk to. Thanks for giving us the new updates on the new stuff. I'm super excited about that. I'm really excited to get some of the installers' feedback on the new stuff, especially with having transmitter and receiver being one box now. I think they're going to really love that. But yeah, thank you so much for your time. I know it's getting late for you, so enjoy your evening, get some nice dinner, and hopefully we'll see you guys at a trade show coming up sometime in the future.
Yeah, to everybody listening in, I mean, again, Jason, thank you so much for having me on.
Sure.
Difficult, crazy times right now, so just everybody be well, be safe, and I look forward to meeting as many of you guys face to face at the next available trade show.
Perfect. Well, thank you guys so much. Thanks again, Danny, and we'll see you next time.
Take care, everybody.
Bye.